Today, every day, small cap investors visit Agoracom knowing this is the day to discover the world's next great company, to have their dreams come true. That's why I take to the open road, to find them, to tell their stories, to engage them, to bring them to life, because they want to connect with you from your office, your phone, your home, anywhere. Agoracom, find your dream.
Welcome to Beyond the Press Release, a production of Agoracom, in which we take the time to speak with small cap companies right after they put out important news. With us today, I'm happy to have him back, Bernard Tourillon. He's chairman and CEO of HPQ Silicon, trades on the TSX Venture Exchange under the stock symbol HPQ. For our friends in Europe on Frankfurt under UGE, and for our friends in the US, URAGF. For those of you who are new to the story, HPQ is in the process of becoming a vertically integrated producer of silicon, silicon powder, silicon wafers, and other products for the lithium-ion battery market in 2020. If that sounds like everybody else, it's not, because the company already has an NDA with a battery manufacturer right now, and they've proven and advanced their process with two world-class technology partners, PowerGenesis Canada in Canada and Apollon Solar in France, who are both world-renowned. The news we're talking about today, this is going to be a doozy of a headline. Silicon material produced with the Gen 2 PureVap offers promising potential to replace graphite in lithium-ion batteries. Bernard, welcome to the show.
Thanks, George.
That's a replace graphite. That's a pretty bold statement. You're probably going to lose some friends in the resource industry.
I'm just going to lose friends in the graphite business. That's
yeah, and friends aside and all that, let's talk about, give us a layman's explanation, because it's a very technical press release, a layman's explanation of exactly what you mean by being able to potentially replace graphite in lithium-ion batteries.
okay. It's known in the literature. It's a known fact, and it's not something that HPQ has invented. It's not something that's coming out of Bernard's head or anything else. Silicon is a much better, because silicon is a semiconductor that works better at high temperatures. It's a very technical aspect, but fundamentally, it can retain, has a better gravimetric and volumetric capacity of retaining energy, okay, in the process. So it's much better than graphite. So it is the material of choice. There are some issues with silicon that are known, but there have been ways that have been discovered to deal with them. So fundamentally, what it is that you cannot increase the capacity of batteries to the level you want to, okay, with graphite. Because, you know, you need so much freaking graphite that your batteries is too big. People want smaller. So if you have a product as a capacity, it's even gravimetric, it's 10 times more, means you use 10 times less. So it's 10 times smaller for the same energy. If it's volumetric and it's 3 times more, well, it's 3 times smaller for the same energy count. So
you're kind of following Moore's law, which is, you know, things are getting smaller and more powerful. We saw that happen in 100 different technologies, and you're saying that's now coming to lithium-ion batteries. So,
well, the key point is figuring out a way to have that theoretical capacity, okay, which is what we have in the graph, and basically make it a commercial reality instead of a theoretical reality. So, and that is where the work we've done with the Gen 2 and the work we're doing with Pyro and the work we're doing at Apollon is trending toward.
So what is it about these results that tell you, you know, that demonstrate you've got the potential to replace? What is about these results specifically?
It's just that we've demonstrated that we could take material out of our, you know, Gen 2 that we've produced, and we get good results. And as we say in the press release, you know, we've been able to address some of those issues that we're starting in our first preliminary test. There's still more work to do, still more things to do. But what it allows what it allowed HPQ and allowed us to understand is what unique position we have in this space. Okay. Silicon's potential is known. It's being worked on. More and more people are going to work on it. But all the people that are doing any type of work in that space, okay, are not silicon metal producers. And the big silicon metal producer, it might be a Walker for the electronic quality, it might be a Ferro Atlantica for the metallurgy grade silicon metal. At the size the market is right now, it is too small for them to be significant, and they don't have and their business plan is not designed to do it. But it's way big enough for us to have an incredibly blue sky potential toward us, because over time we will be replacing graphite. So it's very easy to figure it out how potentially big the size of the market can be right now. You know, just rough numbers that I've done.
Yeah, well, I was actually going to ask you. So if you're, I'm glad you actually said that, because the question I have right here is, so how big of a market are you potentially going after in terms of dollar value and even in volume? Just in how big is that market?
I'll let the people do the math and everything else. Since we're replacing graphite, graphite is a known material that battery manufacturers, because battery manufacturers don't like to change a lot of data points, so they're going to be changing 1 point. So graphite costs them between $10 to $20 a kilogram. Okay, so you have to figure a way to have a material that you sell to these guys where it's going to be in the, how can I say, in the entire mathematicals of their production. Okay, you're going to have to be able to sell them a material at a price equivalence per watt. That's going to give them a much better product. So if you have a volumetric, you know, a gravimetric capacity of $10, $100, if it's $3, $10, $30. So we know the range is going to sell is between $30 and $100 a kilogram. Okay, right now, making the material, okay, it costs over $30,000 a kilogram. So you understand the gap that has to be squished.
How do you get that down to $100 to $200 per kilogram, assuming that you have a 10x advantage? How do you get it down to you can get it down to that?
Yes, because that's sort of a lot of the reason why it's so expensive. It's because, as I say, not too many people in the battery space. A lot of research has been done, and it is just understanding what you need to be producing. So we've been focused on this since the beginning. All right, a lot of the processes that are being used are very physical to make it, but because that's what you can do in lab scale. Okay, but that's just not a process that's scalable. With Pyro, our philosophy is always to look at how can we scale up a process from the beginning. So this is why we've developed, or we're building the nano reactor, the nano silicon reactor. It's using our PureVap technologies. We figured a way to start manufacturing this, you know, the spherical nano silicon powder that the market's going to be looking at very economically. So we can fill that gap. Okay. So the size of the market, if you want to have an idea, in 2018, you know, supposedly global graphite demand was around 392,000 ton. Okay. So you divide it by, so it's going to be anywhere between 32,000 ton of silicon to replace it to 117,000 ton, because divided by 3. It's
even at 32,000 tons, that's a lot of product.
Especially since I think right now the worldwide capacity to do nanoparticles of silicon must be 1 or 2 tons. It's just not there. I saw a press release about a company that was all excited. They were going to double their capacity to do nanoparticles of silicon. They were going to go from 1 ton to 2 ton. This is just, we knew that silicon for battery was going to be big, but we just didn't know when the big was going to come.
And that, given the small numbers you talk about, when does the big come?
It's as soon, you see, it's known if you can make a certain size, a certain form, okay, type of silicon economically, they will come for you.
So, okay? So what you're saying is, it's not as if Bernard has to go out and convince battery manufacturers, hey, I think you should use my silicon instead of graphite. You're saying that it's accepted by the industry that silicon's better. As long as you get it down to certain specs, you don't have to do a sales job. You just got to deliver the spec, and you're saying essentially.
Well, you have to deliver the spec for the cost that they're looking for.
Of course, of
course.
We've
We've always looked at that issue from the beginning. There's some spec that we're uniquely positioned to do, okay? Because as I said, or I think I've said in many presentations, battery space has a tendency to want 3 to 4 N purity material, okay? My competitors, the traditional silicon metal manufacturers, barely can do 2N. So for them to make 3 to 4 needs at least an extra step, okay? Extra step adds cost. Second of all, they have big industrial complex that need about 50,000 tons per plant of annual sales to be to keep operational. So at the beginning, you know, we're not going to take the full 32,000 tons. So the market might be 2,000 tons for the first years. Well, 2,000 tons for the big guys is not big. It doesn't move the needle for them. For us, it moves completely the needle because we're completely structured for this. So this is what we're happening. We really want to position HPQ to be the silicone supplier of choice to battery manufacturers that all will develop their own specific way of doing their batteries. So they're all going to have quirks and says, okay, we want our silicone this way, we want a silicone that way. So what we're trying to develop is a process or a way to make our material cheap, but to be able to meet their demand. And we know
is that now, just to play devil's advocate, Bernard, that's what most companies' challenge is, right? Being able to make the product. How confident are you that, you know, with you and your partners, that you can actually get it down to the cost and have the flexibility to give different, because you already got an NDA signed with the battery manufacturer, so obviously the industry is recognizing you. How confident do you feel in those two ifs?
Very confident. If you just go back and look at a press release about the nano reactor, okay? The nano reactor, we did proof of concept tests, and we did nanoparticle are perfectly spherical, okay, which is sort of very, very difficult, very expensive to do by other process. And we were in the 500 nanometer range with probably some smaller. So we have an idea what range there is. I'll probably issue more press releases to clarify this, because this one was very specific. What I wanted to tell the market, I wanted to tell my investors, and I want to tell potential investors is we've already started to test the material coming out of our pure vat. We already have a relationship with a university doing some tests to validate the end product. We've already discovered one process to do it. And we're working on many others. So our relationship is going to grow with the university. As soon as we start producing samples, we'll send them some more to test and everything else. That's the key point. Second point is, I want my investors to understand how big the addressable market we're looking at. You know, EV vehicle, the green philosophy is not going to disappear, even though what we're going through is very difficult. I think afterwards it's going to be there. Market is massive. So we're looking at an addressable market that's going to be in, you know, supposedly like in 2023, if we take graphite's number and divide it by 10 and by 3, anywhere between 148,000 ton to 400,000 ton per year. That's big. Okay, so there's a market for what we're doing. There's a demand for the product that we're looking at doing. Now we just have to work on doing it. But what differentiates us from everybody else is our thinking is much more commercial scale. Okay, reality is, if I can turn my my material out of my pilot plant, which is 50,000 kilogram per year, into powders, I'm already going to have a leg up over everybody else. But right now my focus is more on how am I going to deliver this, and that's really what it is. So the key message is there. We know that silicone is much better than graphite, and silicone will replace graphite. We've already done some R&D research. We already have built the the maillage between a university and what we're doing to develop some product in that area, in addition to everything else that we're doing. Okay, so we're not like everything is not all hanging on one specific tendency. So that's where we are. That's the key message
And
I really want to come up.
can I ask you a question?
Mm-hmm.
I keep going back to the NDA with the battery manufacturer because that provides that third party credibility where you're not just throwing stuff on the wall and hoping someday you'll have some from the market. Can I ask you, generally speaking,
Mm-hmm.
have you had what interest have you been getting from the market in general? Or is the phone ringing? Are you getting inquiries? You know, and
I'll answer this way because you do understand that if you have interest with any of those type of guys, the first thing they'll do is make you sign a very serious NDA. So we were lucky that the NDA with the first battery manufacturer was a startup. We have more flexibilities. But once you start dealing with bigger boys, they shut up. That's just the way it is. But I'll say this. The pure VAP work that we were doing, and that's a key point I want investors to understand. I wasn't getting call or request or documents to sign what was coming out of what will be coming out of the pilot plant. But where I'm getting a lot of demand, interest, demonstration is on what we're looking to do with that material. Okay, and that's about as far as I can go.
so that's kind of exciting. Some people. All right, that's good to know. Look, because the reason I asked that is it's very rare when a company, a small cap company, I've been doing this for 23 years now. It's very rare when a company gets an NDA with somebody manufacturing in the industry and then nobody else calls, right? Usually if you're on the radar of one company, you're on the radar of others. So I'm kind of glad that you're able to allude to that a little bit. One more question, because this isn't all upside. And there's a quote where you say, it demonstrated its ability to advantageously replace graphite while limiting the disadvantage inherent to silicon anodes. So there is some challenge.
It's a known issue. It's a known issue. It's called swelling and cracking.
How do you guys feel about being able to overcome that where others haven't been able to?
Okay, it's not see. This is the point where people that are too laymen that read the material don't understand it. Okay,
that's why you're here.
That the solution has been found to how to deal with this.
Okay.
At laboratory, which explains why it sells for $30,000 kilogram. The problem isn't how to resolve the issue. The problem is how to make that stuff economically. That's literally where the issue is. That's the point we've been addressing. That's the point we've been looking at the beginning. I've been fully aware for the last year that we're going after graphite. So if we're going after graphite, we have to offer the battery manufacturer a product that is superior at a price that's equivalent or cheaper. It's as simple as that. It's a simple business. It would have been the same thing in the solar business. It's exactly the same thing here. Okay. But we have a unique advantage because Pyrogenesis basically invented plasma atomization. So they've been in metal-based powders for many, many, many years. So, you graph that to HPQ and suddenly you have a company or you have a technical group that have, 20 years legs up advantage over everybody about how to do it. So we have multiple ways of reaching the goal. Then you add Apollon, who happens to own the patent to doing porous silicon metal, which is another type of material, which is another way of reaching it. So,
and that's important for people to know. Yeah. You're not a one-trick pony. This isn't, I just created silicon. There's different variations, very niche, but very valuable variations of silicon. Yeah. And you've got a pretty good handle on most of them, it sounds like, from the news you're putting out. So the question I want to ask you is this, the last question. What is, where to from here? This is a pretty bold press release that you put out. Where do you go next with, the material, this specific material, and maybe a little conversation about the other materials but let's talk about this one without getting too
Well,
lost?
on this one, it's sort of like, okay, we've done the test, we figured it out. There's another reason that we're working on, but what we understood from these tests is it helped us move forward to what we're doing with the other process. Okay, so there's multiple areas around it. I think what we're going to be focused much more is, and as I issued in previous press releases, now it's going to be just, you know, designing the nanoscale reactor to start producing samples. Okay. What I will say is at the beginning, we were going to say we've produced samples in this range and, you know, start offering them. But what's suddenly happened in between is that we've gotten a more keener idea of what the industry is really looking for. So we're taking a bit more of my time to the beginning, instead of like doing try and error, try to get from the get-go the material in the specification that industry participants are going to be, you know, crazy for.
Can I infer from that? Because, okay, can I infer from that? Okay, you just said something there that you're getting a better idea of what the industry wants. Can I tie that back into the question I had a couple of minutes ago where you're getting
you can tie it in many things. First of all, I'm basically stuck at home, so maybe I'm doing a lot of reading on technical material. So you can infer it any which way you want to.
Okay.
But my official position was I've been doing a lot of reading. But you can infer anything you want.
I got to push, right? That's my job. I'm not going to always get there, but just the way you said that, the industry, but you're right. You know what? No one should take my inference as meaning a whole lot, because you could just be reading a ton of materials, and you know, God knows there's a lot of material here, but and you could just be extrapolating from that. So, but I do also note that Cheshire cat smile on you. You smile like a Cheshire cat. So I wonder if there's more, but you know, congratulations again, Bernard, getting to this point. You know, really bold statement about the graphite. You know,
there'll be more. There'll be more bold statement coming up.
All right. Well, if that isn't something to look forward to, I don't know what is, Bernard. But thanks for.
But you won't have a clue where I'm coming from with those. Well, there'll be more bold statement because you know there's a lot of our research that we're doing, which makes us understand how to position ourselves. I'll just give an example. What we're working with Apollon. Like originally, I thought we were going one tangent, and we're going another one, which is even more exciting. So this is what I'm saying. It's like
more bold statements coming. You heard it straight from the patron's mouth. I was going to say horse's mouth, but straight from the patron's mouth. You've been watching or listening by a podcast to Bernard Tourillon. He's chairman and CEO of HPQ Silicon, trades on the venture exchange on the stock symbol HPQ, in Europe, UGE, and in the US, URAGF. You've heard what he has to say. You've watched what he's had to say. You've seen the graphics. You've heard the headline, that's for sure. Your job now is to go do your due diligence. And let's face it, a lot of us have a lot of time for our hands. This is a good time to be doing your due diligence. So get to Agoracom, read the information there. I strongly suggest watching and or listening to the previous 3 or 4 interviews we've done with Bernard, because that's really going to help round out your knowledge. But it's important because we may be looking at, hey, the headline is worth repeating: promising potential to replace graphite and lithium-ion batteries. Whenever you hear a statement like that publicly in a press release, it behooves you to take a deeper dive and do your research and see what you come up with as well. So thanks for joining us, everyone. As you can see, Bernard's at home. You know, I'm at home, even though I got the green screen going on behind me. Continue to stay home, continue to stay safe, and keep our frontline people healthy and out of harm's way as much as possible so we can all get through this. But in the meantime, you're loaded up, you got time in your hands. Please do the research, and we'll see you next time.